Resistance in series and parallel circuits. Now suppose you have a circuit like this one, 3 resistors connected to a power supply of 5 volts. Calculate the total current through the circuit. Now the problem is you don't know the separate voltages or currents, so it's really difficult to calculate the total current. Let's first have a look at the properties of a series and parallel circuit. Now for a series and parallel circuit, you know something about how voltage and current divides across and through the resistors connected. Let's call the voltage across the total circuit V total, and the separate voltages V1 and V2. Likewise, you've got a total current and a current through resistor 1 and 2. But let's not fill that in our diagram, it would become too cluttered. Now for a series circuit, you know that the total voltage equals the voltage across resistor 1 plus the voltage across resistor 2. And for the current, you know that the total current equals the current through resistor 1, which equals the current through resistor 2. For a parallel circuit, we know that the total voltage equals the voltage across resistor 1, which equals the voltage across resistor 2. These are just the same. And the total current is the sum of the two separate currents. Now for resistance, we do not have a formula like this, and it would be really convenient to have one to calculate the current through our diagram at the start of this video. We can find these formulas for the resistance in a series and parallel circuit by using the formulas you see here. Let's first have a look at a series circuit. Now suppose we've got a series circuit and we call the two resistors R1 and R2. So we know their resistance. And their task is to find a formula for the total resistance. Let's start by using this formula. Or we know that R total equals V total divided by I total. Total resistance, voltage and current. What do we know about the voltage? Well, the total voltage is just the sum of the two separate voltages. So V1 plus V2 divided by I total. We can separate this in V1 divided by I total plus V2 divided by I total. Now what do we know about the total current? These are just the same for the two separate resistors. So we can write this as R total equals V1 divided by I1 plus V2 divided by I2. And you can recognize this as the resistance of resistor 1 and the resistance of resistor 2. So we can write this as R1 plus R2. Let's fill this in our diagram. So for a series circuit, the total resistance is just the sum of the two separate resistances. What about parallel? Let's start with the same formula for the total resistance. V total divided by I total. Now what do we know about the total current? It's the sum of the two separate currents. Let's fill it in. V total divided by I1 plus I2. Now we can't separate this because the sum is in the denominator. But we can get it in the numerator by taking the reciprocal. So 1 divided by R total equals I1 plus I2 divided by the total voltage. And now we can separate it. So this is written as I1 divided by V total plus I2 divided by V total. What do we know about the total voltage? They're just the same across the two resistors in parallel. So we can fill it in. 1 divided by R total equals I1 divided by V1 plus I2 divided by V2. And here we recognize 1 divided by the resistance of resistor 1. So we can write this finally as 1 divided by R total equals 1 divided by R1 plus 1 divided by R2. Let's fill it in our diagram, which now is complete. This formula, it's a bit odd, is the formula for the total resistance in a parallel circuit. Now let's use it in our problem. Calculate the total current through the circuit. We know the total voltage, and we know the separate resistances of the resistors. If we know the total resistance, we can calculate the total current. I equals V divided by R. Now, what is the total resistance? Let's first calculate the resistance of the two parallel resistances using the formula we've just derived. 1 divided by this parallel resistance is 1 divided by 3 plus 1 divided by 6, which equals, let's use the calculator, it's a half, 0.5, but this is not the resistance yet. Remember, it's 1 divided by the resistance. So the resistance itself is 1 divided by 0.5, which is 2 ohms. We're not there yet. We need to add the series resistance to the parallel resistances. So the total resistance equals 2 for the series resistance plus 2 for the two parallel resistances, which equals 4. Finally, the total current equals the total voltage divided by the total resistance, which equals 1.25 amps. And this concludes our video.